Hey everyone, thanks for joining us for today's virtual event, Modeling for Success, Building Data Structures That Last. I'm Leah Houston. I'm a Senior Campaign Specialist here at DBT Labs, and I'm very excited to be kicking off today's event. Okie dokie, let's get into today's housekeeping. So we have a Q&A tab. Please use that Q&A tab for all of your questions, and a DBT product expert will answer them for you. We also have the chat tab. Please continue to use that for banter about the presentation and have some fun with us. Etiquette, please be kind to your fellow attendees and presenters. We want you to ask the tough questions, share feedback. We're glad that you're here, but let's keep it respectful and inclusive. Recording, yes, we will be sending out today's recording within 24 hours after this event, so be on the lookout for that in your email inbox. And then lastly, we'll be sending out a survey at the end of today's session. Please take that survey for us. We'd love to know your feedback and how to improve these sessions for you in the future. So today's virtual event is part of our Modern Data Fundamentals series with phData. We hosted the first session from Stored Procedures to DBT, your playbook for successful migrations, a few months ago. If you missed that, no worries. We'll drop a link in the chat for you to watch that on demand later. Today's event is the second episode in our series, Modeling for Success, Building Data Structures That Last. So for today's special event, I've suited up in my Vault Dweller gear because we're coming to you live from the DBT Labs Vault. If you've never played the game Fallout before or seen the show, here's the idea. In those stories, people survive disasters by living in underground vaults. You can think of it like extreme doomsday prepping. You build your vault right, and you've got a safe, sustainable place to thrive. You build it wrong, and things get messy very fast. That's the same way we're going to think about data modeling today. Your data model is your vault. It's the foundation that everything else depends on. You get the design right, and your analytics can scale safely and reliably, cut corners, and you risk fragility, chaos, and costly repairs down the line. And in analytics, just like in the wasteland, your survival depends on your data model design. So today's session is really about one thing: how to prepare for the future with modeling strategies that keep your data strong and sustainable. Whether you know the game or not, you'll see how thinking about a vault helps bring these strategies to life. Okie dokie, I'm going to pass it over to our presenters, your data survival strategists. Over to you, Stephen.
Cool. Thanks, Leah, for kicking us off there and getting us going with this new webinar that we have. My name is Stephen Robb. I'm at Partner Solution Architect here at DBT Labs. I've been here at DBT Labs for now around 6 months, but I've been in the BI space and computer science space for a long time now, over a decade. I'm really looking forward to kind of talk with you about data modeling today and best practices. And I'm being joined by the great team of phData over here, who I've already had a couple of webinars with in the past. So check those out if you haven't seen those before yet. But let me go ahead and hand it over to them, and we'll get started.
Yeah, thanks, Rob. Thanks for the intro, and thanks, Leah. My name is Dustin Dorsey. I'm a data engineering director at phData and also one of the co-authors of Unlocking DBT. The second edition just finished it. It's available now, so you can check it out through any major book retailer or Amazon, which is a full in-depth look at DBT end to end. Over to you, Dakota.
Yeah, nice to meet everyone. I'm Dakota Kelly. I'm a principal solution architect over at phData, where I've been here for about 4 years now. So I've been working on the data space for a long time. Excited to hopefully demystify modeling for everyone and um, show everyone what we can do. But also, don't forget to come meet us at Coalesce as well, because Dustin and I will be there. So if you happen to be at Coalesce, don't hesitate to reach out. So real quick, before we dive deep into modeling, just to give you all some background on who phData is, who Dustin and I are. phData is really one of the top partners of a lot of the top tech stacks. That includes DBT, that includes Fivetran, that includes Snowflake. We've been a repeat partner of the year. We are frequently diving deep into every piece of technology in the modern data stack, and we are here to help answer any questions and demystify anything you want to know about any piece of the modern data stack. And so with that, let's jump into the agenda. Really what we want to uncover here is, what is a data model? And how does data modeling different from what we call a DBT model. What are the types of data modeling paradigms? Now, there's a number of these paradigms that we will go over, and I think the three of us could sit here and talk until we're blue in the face and turn this into an 8 hour session, just trying to get through all of them. So what you'll see is we're going to start by focusing in on dimensional modeling. And that's where we'll lean in next after covering the different paradigms and where they make sense, followed by a little bit of a real world example where we'll walk through a set of information you might receive from a business user, kind of show you an example, very simple, but example ERD of what you would build out based off of that, and then cover some of the real world lessons we've all learned throughout this process. And so with that, I'll hand it over to Dustin to talk about how data modeling and DBT modeling are different.
Yeah, so thanks, Dakota. So yeah, let's dive into this a little bit. I want to add a little bit to just kind of help set the context for this presentation. So me and Dakota both obviously we're at phData and we work with a lot of different customers, big customers on DBT implementations. And quite possibly the number one thing that we see when working with customers in terms of issues relates back to the data model. So this is something very near and dear to our hearts because it's a place that we constantly work with customers on. And when we go in and we meet with these customers, their perception of what a data model is and why it's important is often very skewed. And a lot of folks think, hey, this is something we did 20, 30 years ago, but it's not really relevant today. And in actuality, it's still very, very relevant. So, really excited to dive into this topic. Again, it's something we're really passionate about when we do it. So, let's kick it off with where a data model is not equal to a DBT model. So, big thank you to DBT for making this really confusing for all the folks out in the data community by calling your SQL and Python files models within your project, but they are not the same as a data model in the context of what we're going to talk about in this presentation. A DBT model is a file of transformation logic, or it's a file in your DBT project. So it's a lot like think about it in terms of I know we're doing our Fallout theme here, like a holotape. It's a single file. Whereas a data model, when we talk about it in the context of here, this is the blueprint of your data design. This is what defines how your data is organized, stored, and connected in a system, and it can span many DBT models. So your data model itself, it's going to have a bunch of DBT models, and a DBT model is going to be a single component like that. So you can kind of think about the data model as a crafting recipe that you would have multiple ingredients that would go into this and build it. So what we're going to talk about today specifically is building that blueprint of what you're going to work on as you go into it.
And I will say, as a DBT rep, I would challenge the audience to come up with a better name for a DBT model. Go ahead and throw that in the chat.
Love it. All right. And so I kind of already iterated or kind of already stated this, but one of the biggest issues that we see with data teams today, and this is coming from a consulting perspective, is that we often see them get lost in the short-term solutions and they never stop to consider the big picture. This is something we see time and time again. Like one of the best things about DBT and also maybe one of the toughest that we see is DBT is a really easy tool to get started using. And so a lot of teams will pick up this tool, they'll go in and they'll immediately start going in and developing and they'll start bringing value. And ultimately what they find out is they do this for a period of time and they hit a point where it no longer scales. And the reason being is because the tool was so easy to get started using, they jumped into it and started building without ever stopping to think about the big picture. They're looking at the short-term solution where someone comes and tells them, "Hey, I need you to get this report out the door." It's like, okay, I have this really simple tool. I can go in and I can build some models to do it. And that happens time over time over time. And again, you hit that scalability problem. So what we want you guys to all take away is stop and think about the big picture of these tools. Even though DBT is, and we're so grateful for this, is so easy to be able to use, it's still important to think about that big picture of what you're doing here.
Yeah, and you'll see here when you get lost in all those details, it can kind of be like standing next to some radiation in the Fallout games.
Yep.
All right, so let's dive into what are some of the different types of data modeling. There's a number of different types that exist out there, and we're going to talk about four here, but there's even more than this. Really, what we want to talk about is the difference between normalization and denormalization inside of these. Think of each of these types of data modeling like a different vault inside of Fallout. The more normalized it is, the more it is built for write optimization. So we're trying to optimize for processing transactions, making updates, writing new records, etc. That's why you often see the third normal form as kind of your standard that you seek to achieve when you're writing or creating an operational system. However, what we often find is when we're doing analytics, we have a lot of data we need to read. We're not often processing a lot of data or having, you know, hundreds of thousands or millions even of transactions we need to process at a time in. We need to read data out. That's where denormalization starts to take effect. Thanks to column stores and features like that, it makes reading very efficient. And the more we denormalize the data, the easier it is for that process to read and understand um, how to optimize the query. However, that doesn't mean that one of these is better than the other. They all have their strengths and weaknesses. And like I said, there's even other modeling paradigms that we don't call out here. I want to stop here real quick. Dustin, Stephen, anything you guys would like to add to that?
Yeah, I think it's a good call out. There, I will add, even when you're looking at these different model types that are here, you'll often see where folks will kind of pull hybrids of these. You see this especially a lot in dimensional modeling. We're going to talk a lot about dimensional modeling in this presentation, mostly because DBT is really a batch-oriented tool, which plays very well with dimensional modeling. But it's pretty common to see teams kind of take principles from like maybe even all of these or a portion of these different types of models and then pull them together, or use even different types, as you alluded to, Dakota. Just to call out some of those is there's open data models for specific industries. There's no data model, which is a model in and of itself of not choosing to model is a type of modeling, and several other different things that exist out there. And you'll have to figure out based on your specific business use case of which one of these makes sense for what you're doing.
Yep.
And I would just say I've seen a lot of data models out there, intentional and unintentional. So it's good to start to identify with the kind of problems that you're trying to solve and then land on the kind of the right tool for it. Like there's no universal right tool, but this is kind of guidelines of helping you to understand when and where to use and apply some of these kind of philosophies.
Yeah, very much so. And so with that, I'll hand it over to Stephen to kind of talk through some of these common patterns.
Sure. So let's talk about a couple of these here really quick. So we have the data vault, the third normal form, dimensional, as we kind of said, and the one big table. The data vault is going to be, one sec. The data vault's going to be kind of this highly scalable solution, but it's going to be a little bit harder to kind of design and implement. And so that's going to be something that you're going to see in this list is that we're going to have specific pros and specific cons for kind of each of these different data modeling strategies. So, for example, while the data vault is highly scalable, it makes it really easy to add additional solutions. Up front, there's going to be a lot of complexity. So, like a real life example could be something like you're trying to bring in multiple different marketing platforms. How do you want to integrate those different data sources together? It's going to give you a framework that is going to solve that problem of now it becomes really easy down the road because we did the upfront work to be able to add these different solutions. Something like third normal form is going to minimize the redundancy and dependency. And that's going to be something else that you're going to see really kind of that moves in different ways between a lot of these different forms, is there's always a trade-off between the amount of joins and redundancy and kind of dependency that we either embrace having a lot of those or less of those to either make it more simplistic or to increase performance or any of those kind of different levers that we kind of care about. So just at a high level, I'll go through these and then I'll open it up for discussion. But so the third normal form, minimal redundancy, pure isolation, highly structured. It's pretty efficient on the storage side, but you have some really complex queries for reporting specifically. With the data vault, it's like every decision is going to be tracked. There's a full audit history, so it's great for those like high governance use cases and really flexible integration, like I said earlier, in that it becomes easy to scale once you've put the initial work in. But it does tend to be very complex to implement, but highly scalable. So you might want to partner for some assistance there. The dimensional model, which we'll talk a little bit more in depth about later too, is optimized for specific use cases. It's going to be pre-aggregated for your performance, and it's going to be great for analytics, but a little challenging to change. Probably one of the most popular models that I saw specifically in the BI space, just because it tends to play really well when it comes to tying data to your business challenges and then kind of serving that up to your users. And then lastly, our one big table in here, everything preserved in one place, simple to access, doesn't necessarily scale well, but it does have really high redundancy. And everyone's seen a one big table, whether that's pulling data from an Excel report or some really unfortunate, massive, large tables from some data warehouses. How do we process that? All challenges kind of talk about. So yeah, anything from the PH data team?
Yeah, I
Yeah,
think
no,
one
I think
thing
that, or go ahead, Dakota.
No, I think one thing I would add to this is that understand that each of these, again, they have pros and cons. Your data vault might take a lot of engineering resources to stand up, but there's a certain scalability and uniformity you're going to get. And you're going to be able to see every change that has ever happened. And you need to understand, does having that level of change understanding make sense for my business? Are we ready to take that on? Do we even have use cases around that? You need to also understand the tools that are connecting and integrating with the data because some tools and some visualization tools prefer certain structures of data. They're going to run more efficiently. We should make sure that we're taking a step back and we're thinking holistically. What's our business needs? What's the business process we need to solve for? And what can our visualization team and tooling actually consume and understand?
Yeah, no, I think you hit the nail on the head there, both of you guys. The last thing that I'll mention just on this slide is you will come across or see sessions or see blog posts or articles that are written that try to tell you only one of these is a good answer and acceptable. I'm personally a huge fan of dimensional modeling. I've spent a lot of my career building dimensional models, but even I can look at this and say, depending on your business use case, can determine there may which model you use, and there may be a better option for what you're trying to do. So just take it with a grain of salt as someone saying, hey, if you're using this tool, the only thing you can do is X model, and if you do anything else, you're going to fail. That's generally not true, and you can use any of these and even use them in combination with each other.
Not only
With that,
that,
let's go. We'll go ahead and kick it over, Rob, if you want to kind of talk about maybe some examples of how people have done this.
Yeah, so what we're showing here is probably one of the most popular kind of buzzwords in the data space the last couple of years, which is the medallion architecture. So what you see here is like the bronze, silver, gold, and platinum kind of methodologies. It goes back, if any of you are software engineers, to dev, stage, prod, however you kind of want to break it down. But the idea here is that we were able to kind of break these down into listing one of the different kind of methodologies that we talked about in the last slide to each of the different stages of your data kind of pipeline. In that you start with your raw data, you build that relational format to kind of store all this data that you're bringing from a bunch of different platforms. Now you start maybe as your company grows, adding that silver layer, which is, okay, how do we start processing this data to start beginning to solve these challenges? And then you get more to these kind of last two stages here. And these data models aren't necessarily going to play out like this every single time. We're just using this as kind of an example. But the idea is that you're going from this very kind of rough place to a much more specialized and focused kind of like business outcome as you work from left to right here. And that now our gold, our data's been separated. We have to have facts and dimensions. It's going to be pretty high performance depending on like which tool we're having interact with that data. And then in the last couple of years, even after we had the bronze, silver, gold, now I've heard platinum, or even out there some weirder ones like uranium, very Fallout themed, which is like how we then maybe create like an analytics version of that. So that's really like that last view just for consumption from our data. Any perspective from you guys, Dakota and Dustin?
no, I think that really hits it. Like we said, at the end of the day, think of this like a refinement process. You're going to build out into different areas. It's possible that you combine some set of these modeling paradigms. Just be cognizant of how, when, where, and how you standardize that so you make the best use of your tooling.
I just want to say refinement, nice, keeping the theme
Yeah.
going.
Yeah.
And also don't think you have to use all of these. Again, use them according to your business use case. Just because you have a silver layer doesn't mean it has to be a data vault or needs to be something specific. Like keep your model as simple as it needs to be while still accomplishing what your business need is. So don't think you have to take these and put them all together because it's going to make you a better engineer. You're only going to make life more difficult on yourself. Do the least possible to accomplish what you need to accomplish from a business perspective.
So,
All
Uh,
right. Yeah. Jump into this one. So why dimensional modeling wins? So why do we do dimensional modeling? Well, let's talk about, I mentioned this earlier in the presentation, but hit on it just in terms of DBT. So DBT is pretty synonymous with dimensional modeling because DBT is predominantly a batch processing tool. Although that might be changing at some point in the future, at least that's the case right now, is it's predominantly done batch processing. When you're doing batch processing for analytics, dimensional modeling is usually the best selection to do that. Kind of going back to, again, some of the things that we mentioned earlier. And there's a few different reasons why that's the case. But before I give you the reasons, let me kind of go back in history a little bit and kind of talk about where we came from with dimensional modeling. So this is a concept and that has been around since around in the 90s at some point. So there used to be a group, the Kimball Group, they're retired now, who came up with this design. And it was largely meant to solve two key issues when they originated it. And granted, this is in the 90s. Technology looked a lot different, and there may even be folks on this call who weren't even born when this stuff was originating. Maybe your parents or grandparents were building these things. But it was meant to cover two core issues. One is deliver data that's understandable to the business users. So take data that's from its raw, sort of crazy format and get it into something that can make sense to a business user and deliver it fast. A lot of folks will argue, or I won't say a lot of folks, but there's folks out there who you'll read blogs from and see in presentations that will tell you dimensional modeling doesn't make any sense anymore because of the advancements in technology and infrastructure and other things. Storage is significantly cheaper than what today than what it was back in the 90s, in which you really had to think about this. But I actually think that negates some of the other benefits of what makes dimensional modeling most important, in my opinion. And one of those is delivering data that's understandable to business users, getting it into a format that a business can look at this data and be able to understand it and enable things like self-service analytics. So when you think about it kind of going down, we have seven just, and there's a lot more benefits that we could certainly add to this, but seven sort of core benefits of why this is important. Number one, it aligns with business needs. So you're building things according to the business because you're making it understandable to them. Two, it greatly simplifies the data because you're building data in a business friendly format, column naming, column values, how you're structuring these things. They're very user friendly for a business user to go in and understand these. Unlike transactional systems where you may have things like IDs and bit columns and all these other different things that exist in there, a business user is not going to understand. You basically need to kind of understand how databases work in order for those to make sense. Whereas in dimensional models, it's generally pretty easy. You could, in its simplest form, you could put an Excel spreadsheet on top of this, and then a business user could go in and make sense of the data. Third, builds a single source of truth. So you're building things one time, something we see a lot in a lot of the models that we review of people who've done these implementations, is you've got the same value as replicated many times over within a DBT project. Fast query performance, this falls on the denormalization scale, whereas if you remember, that's going to be faster reads, slower writes, but faster reads, so you're going to be able to consume the data a lot faster. Modular and scalable. There are fewer DBT models to build, run, and maintain in terms of your project because you are building towards single source of truth. And then ultimately, these are the best model for BI tools. Think things like industry leaders like Tableau, Power BI that sits on top of these. These are built to sit on top of well-constructed dimensional modeling to get peak performance from those. And I'll pass it over to my colleagues here to add any additional information.
Yeah, I would just say coming from when I used to work at a BI company, one of the first questions we would ask is if they're like how they were doing their dimensional modeling. And we would really hope that it was already in effect in dimensional style. Because as they said, anytime you're trying to plug a BI tool in there, especially if you have more sophisticated use cases like self-service, you pretty much have to have a data model that's going to be in some sort of version like this to allow any sort of business user to be able to interact with it in a way that's going to be valuable.
You guys have hit the nail on the head. At the end of the day, it's about aligning these things to a business process, because then the business user understands what's built and how to use it. There you go, Stephen.
Okay, so how do dimensional models work? It's pretty straightforward. It kind of does what it sounds like, facts and dimensions. So facts are going to be your tables that are going to store your data about the business process, and your dimensions are going to be all of the kind of descriptive information that lets you group and filter your fact measures by. So the cool part about this is, as we just said, with like BI tools, it's really easy to start thinking about because facts are going to be your total revenue. It's going to be your total number of like your population. And then your dim tables are going to be how you want to ask questions on that data. So like, if we want to see our sales data by a certain time period, if we want to look at demographical information and ask questions on these kind of various sources, it's really intuitive to start working from that because you immediately start understanding, hey, this is a fact, this is a dimension, and kind of work your way from the business problem to how your data should then be structured.
Yeah, and one thing to add here is I know everyone's probably heard these terms before, facts and dimensions, but just because something within a project is called a fact and dimension doesn't actually make it a fact and dimension. Just like in the world of Fallout, just you can call a rad roach a scorched beast, but it doesn't make it true. Here, similar things. We see a lot of folks who use those naming, but when you look at them, a fact is really just it's a one big table that's just disguised with a name, like a fact is sitting on top of it. Or you see dimensions and they're more of like relational sort of objects that may live in a silver layer, but they're called dimensions within their models. We're going to go into more detail here about how you should be thinking about these things when you're doing your design. But I do just want to call out just because they're labeled this doesn't mean it's actually what they are, and you're doing it in a good way that is scalable and going to work great moving forward.
No, I think that's excellent. But I think real quick before we get into some of those details, let's chat about the difference between the star and snowflake schema, because that often comes up, Stephen.
Yeah, so the star schema is going to be kind of great for your analytics dashboards. It's got clear fact and dimensional separation, and I'd say like typically relatively simple joins. The snowflake schema is going to normalize the dimensions a little bit further, which can be good for reducing duplication, but typically adds a lot of join complexity. So there is actually a difference between these two, even though I'd say sometimes people think they're interchangeable. And like the kind of level that you go down to when it comes to the normalization versus denormalization of the data. Um, anything for you guys to add there?
Yeah. Yeah, the Snowflake kind of tends to make it more transactional in nature, which takes away some of the benefits of doing dimensional modeling. I can't even think of a single scenario where I've recommended a Snowflake design. I don't know if you guys have ran across use cases where you would see that, but in most cases, a lot of places where I see that actually end up doing this, they do it because it makes the transformation simpler. To get it into a true sort of star schema, you're making the data really simple to consume, but you're putting a lot of additional overhead and emphasis on building those transformations. So typically because you're taking like normalized data and you're making it denormalized, that transformation logic can get pretty complex, but you're taking the complexity away from the business and you're putting it on the back end. And when you go into Snowflake, it makes it easier on the engineer who's building this, but it makes it harder on the consumers to be able to consume from it. So not a fan of Snowflake schemas when we see those. I'd rather put in the extra work to get it into a star schema.
I think the only time I've seen that really make sense is when you're trying to have like governed row level security, where you take like a hierarchy and flatten it out into a single lookup for everyone to use. Think like you're trying to separate out data by region or something like that that you plan to apply. I think those are the areas where you can sometimes see this hybrid where things are predominantly a star and you might have one or two kind of snowflake attributes. But I agree. I think otherwise we should definitely try and stick towards star. I tend to favor that more.
Mhm.
Okay, so let's talk a bit about dimensional modeling. What are we trying to do here? At the end of the day, we're trying to separate out what are our measurable facts from the descriptive attributes that we want to use for analytics. And we'll hit on this several times in a way I always like to think of them is think of your facts as the verbs. They're the things that are happening. They're the events inside of your system that you want to do analytics on. And your dimensions are your descriptors. They're descriptive. They're your nouns. They're the people, the place, those type of nouns that tell us what is going on inside of our system. They start to become the things that we would filter by, etc. We can then start to build this out into a star scheme approach where we have the centralized fact table. The fact table should be built around the business process you're trying to model or you're trying to solve, with it connecting to the descriptive information that someone would want to slice and splice the data by. That allows us to bring everything together into a very intuitive and easy and performant manner, especially when you start talking about complexities such as, say, date values. Every organization runs on a different fiscal calendar, or the vast majority that I've worked at have run on a different fiscal calendar than the actual calendar. Well, it gets a lot easier to start to analyze data based on those differences in calendars if you have a good date dimension, those types of things. You might be wondering, okay, well, what does this have to do with DBT? DBT Cloud allows us to bring a lot of these things into our best practices. They allow us to modularize our transformation into reusable models, building out proper facts and DIMs. We can build those out into different teams, and those can be using the mesh brought into different areas, and teams can reference them, can look at them, can build those out. We're able to focus on making sure that our models are well documented, tested, that they are clear, and that they are reliable for those team members. We're also able to build out those medallion layers where we can bring in sources and staging layers and intermediate layers. Think of those as acting kind of like the bronze, the silver, the gold modeled layer where we're starting to build out our facts and dims, and maybe even that platinum pre-aggregated, pre-calculated layer. We do all of this inside of DBT while making sure we bring good testing, good analysis, make sure that we're maintaining our referential integrity, our uniqueness, making sure that we're avoiding model drift, etc., inside of our platform. At the end of the day, we're using DBT because, again, it's the different pieces that are going to build out the fact and dim, but the data model itself is that big picture of how we bring everything together to streamline our analytics and ensure consistency of our data. And so with that, you might be wondering, how do we start to put these things together? You can actually use a bus matrix. I know this feels very old school, but it often helps us start to figure out what are the grains of our data, what assets need to come together to form the facts that we're trying to calculate on. We can start to figure out what are the business processes, what's the grain of those, what things do they need to go across? What are the different dimensions that seem to be common across my organization that I should start to build out? One of the things you'll notice here, there's kind of a light orange on customer and location, which are a little bit of an SCD2. So not only is that a dimension, but it's a slowly changing dimension. So customer information can change. You might be wondering, well, what's that? Well, that's like we as people, we move. So my address today could be different than my address tomorrow, which could be different from my address from a year from now. Those sort of things, we might want to capture that change and understand, okay, where did that order go at this point in time when Dakota ordered this object from us, but he moved to this next place, etc. Dustin, Steven, any extra information you want to throw in there?
Yeah, just to add to this, and we probably should have mentioned this even beforehand. So when you're building out the bus matrix, this is generally information you're collecting from meeting with your stakeholders and meeting with the business. So the first step in building a dimensional model is really you need to have conversations with your stakeholders. You need to understand what's important to them. Generally, they're not going to be able to talk to you in technical terms, like tell you like, "Oh, I need you to go get information from this table and I need you to put it together here. I need you to build these facts and dimensions." They're going to have no idea what that stuff is. But they can tell you from a business perspective like, "Hey, here's the business processes that are important to me, what I need to track." And when I need to group and filter that or need to aggregate it, these are the values that I need to be able to do that by. The bus matrix is a place for you to visualize that information that you're collecting from your stakeholders to put it in a format that can make sense to anyone. Like typically, I could take one of these and I could show it to my business user and say, "Hey, look, here's the business processes that you outlined to me, and here's the different dimensions that it's going to need to be able to connect to, based on what you told me you needed to be able to group and filter by." And they can generally understand this pretty well. The grain, they're not necessarily going to understand, but I personally like putting the grain in there because me as an engineer, it helps it make more sense to me. And the grain is the lowest level of granularity that that object would go to. So typically when you're designing it, like your business processes are ultimately going to become a fact table, and then the top row are going to become your dimensions. And when you're building your business processes down to the fact table, you generally want to go to the lowest level of granularity that you'll need to be able to serve for not just this specific use case, but also for other use cases. So maybe one team maybe only needs to see order at the total order level, but you have another team that needs to see it at the line item level. So maybe you would build your grain would be doing it at the line item level as opposed to doing it at the total order level. And then you could always stack a fact table on top of it or handle that in reporting a little bit later. But the key call out here is just know as you're meeting with your stakeholders and you're gathering information, again, before you do any development and you're gathering this, this is a really good tool. It's been around forever just to be able to visualize that and put it into a format to be able to track it. And it's something you can iterate on over time as you add more dimensions, as you add more business processes. This is a growing document for a place to be able to see your model.
Yeah,
And the
exactly.
only thing I would add to this is we're not going really deep into like the DBT specific functionality on these. We're keeping a lot of this at kind of a high level, but also for times like this where you see like, hey, here's four different business processes in DBT. This might be represented as multiple DBT projects that we're combining with mesh. So realistically, the DBT structure is also going to apply to how you kind of build this dimensional and fact model based on which features you use, kind of where and why. Um, but going back to the great talks by them, business outcomes is the most
Yeah,
important.
exactly. Exactly.
Yeah.
At the end of the day, we don't want to make assumptions about our business. We want to make sure that we're actually facilitating our business to make decisions. So all of these things should come from the perspective of what the business needs.
Yeah.
And so, how do we translate what the business needs into a set of facts and dims? Well, there's a number of different things you're going to hear as you're meeting with the business, as you're meeting and talking to the business around what their business process is. Over time, you're going to start to realize commonalities that help you identify what are the fact tables. Because at the end of the day, your business process and the events in those are what should become your fact table, which are the identifiable and measurable events, things like sales, transactions, shipments, etc., that you would want to start to actually do aggregations and calculations on. And much like Dustin said, your initial analysis might go, oh, we just need things at the order level, but you have line items. You might want to go ahead and start at the line item level because it is always easier to aggregate up than it is to aggregate down or deaggregate, I guess I should say. That's probably the right word. Um, from there, we want to make sure that we're answering our key business questions, which help us define the grain of the data that we need, which again helps us figure out what is that lowest level of detail needed so we can start answering questions. But also, if we're at that lowest level, it makes it easy for us to start to aggregate up, answer new questions or questions we didn't even think about initially. We want to make sure we understand what our business entities are because those start to become our dimensions. Those are things like what are our customers, our products, the time, the regions, etc. Those different things we're going to want to filter by and build out. We want to understand what are the metrics and KPIs we want to calculate. Those can help us identify the initial measures that help us make sure that we're able to get to the correct grain. Are we trying to measure revenue? Are we trying to measure the quantity sold, cost, margin, things like that? We also want to understand what is the relationships and the context of those relationships within our data. What sort of attributes make up the connection of products and their categories, the customers to the different segments, maybe even the sales territories that we sell objects into. We want to understand those sort of hierarchical relationships that start to exist and can help us start to roll things up into new hierarchical analysis. The goal at the end of the day is to build a dimensional model that mirrors how the business thinks and operates, allowing them to have a clear and fast and accurate reporting of what has happened. Anything Stephen or Dustin you guys would like to add to that?
I would say another benefit of thinking about it this way is that typically you also get ahead of the data asked by some of the business users. So if you're structuring the data in this kind of format where you follow this kind of patterning, a lot of the times the users will already have the dimensions that they want to ask questions on that they weren't thinking about until later because you've exposed it, you've created those relationships, you've listed possible metrics and KPIs and broken up in that kind of fact and dim style. It lets them start asking a couple of questions and then go to like the next question without getting bogged down by tickets as fast as it is possible.
Very much. With that, I'll hand over to Dustin to walk us through how to create facts and dims.
Yeah, so we'll jump right into it. So we've already kind of hit on this in the past few slides, but just understand that facts are directly tied to business processes. So facts represent those things that can be measured. So an example here would be some of the examples we already mentioned on orders, could be other things like shipments, payments, website visits, etc. What's important about this when doing dimensional modeling, and a place that we see teams oftentimes fail on this, is it kind of goes back to building single source of truth. In my overarching model design, if I need to evaluate orders, there's only one fact table for orders. So I'm going to create one fact table for orders to kind of build for that business process. And then I'm going to add different measurable columns onto it that can accomplish the different business needs. If someone needs something related to orders that fits that grain, they know they're going to go to that one single table to be able to get that information. What happens a lot of times is, again, kind of using the example of orders, is there's going to be different variations of orders that are going to fit for specific business needs. And you see folks build DBT models that will go for that individual specific need as opposed to just building that one core table just one time to live in your model. So that kind of becomes your foundational layer that everything else can build on top of it. Think about things that you can put on top of it, like semantic models or AI or even BI use cases that sit on top of it. It's important to have one place to go look for that and not have that data spread out across multiple other models. The granularity, so we've hit on this. This determines the level of detail. So how low does it go? And so when we gave the example of orders, do you do it at the order level, total order level, or do you do it at the order line level? You usually want to start at the lowest level of granularity that you need. Again, as Dakota mentioned, it's easy. You can always aggregate up and I can stack things on top of it. I can't take something from the total order level and then get it down to the order line level without going back to my source data to be able to get those. So typically I want to stack because I want to build that single source of truth. Facts also have measurable columns. So these are going to be numeric columns that are going to exist, something that you can aggregate. Think about I can count, I can sum, I can average, um, I can pull some sort of thing from it, right? These would be things like sales amount or quantity or discounts, but generally numeric in nature. And then your foreign keys. So your foreign keys within a fact table are going to relate back to a dimension. It's generally you want those to be a single column value because it's going to make those joins a lot easier. So a lot of times what we'll do in terms of building warehouses is we'll use surrogate keys, or maybe the grain of a table is made up of multiple business keys that exist in it. So an order could be like an order number plus an order line plus maybe even an order date to be able to determine that grain. But in order to build those dimension keys, what we would do is we would create a surrogate key or a hash of those that we could create that single column key. But typically, you're going to have foreign keys that's going to exist within your fact table that's going to allow you to be able to join back to your dimensions using a single value. And that's all built into your transformation process. So ultimately, fact tables translate everyday business operations into measurable data structures, and it really forms the foundation for analysis and reporting.
Mhm.
Now, kick it over to you guys if you have anything to add on that.
I
No?
think that was Perfect.
All right, sounds good. And so in dimensional models, we've kind of hit on the facts here. Okay, now we have the dimensions. Dimensions are business entities. So they describe the who, what, where, when, and how. And they're typically things like nouns, like people, places, things, concepts are going to be dimensions. When I think of dimensions in terms of dimensional models, I often think about dimensions like master data because you're typically building them one time for your entire project. So if I have a customer dimension, it's a master data element that exists for my entire project. So it doesn't matter if I'm looking at financial data, supply chain data, inventory data, marketing data. I still have one look at a customer that exists for my entire project. What I've seen a lot of customers do is they'll build dimensions according to specific marts. Marts being subject areas that can exist within your DBT project, and they'll recreate those dimensions over and over and over. You only need those to be created once, and then you can iterate on those over time as you have more and more attributes that need to be added to it. So again, dimensions can be things like customers, products, employees, locations, time, to give you some examples there. Attributes. So these are things that provide like descriptive context. So for a product, this could be like a product category. For a customer, this could be a customer segment. If you've got a location, this could be things like an address or a region or a country. You also have keys that exist within your dimensions. So as I mentioned before, when we join those into our create the foreign key relationships within our fact tables, these are the keys you would want to create a surrogate key on your dimension table to effectively create that join key. Are you guys getting any feedback? There's a bad rat storm going on outside. I don't know if you guys can hear that coming through on the camera, but it's quite noisy here. Other things that come through on the dimensions, so you need to determine if you need slowly changing dimensions. So there's a lot of different types of slowly changing dimensions. I think it goes up to, I don't know what the total number is, maybe type 10. There's really the first type 0, type 1, type 2 are going to be the most predominant. A type 2 is where you track history within a table. And that's the one that you typically want to know if you need to do. Otherwise, you just override or replace, which would be your type 0 and type 1. And then lastly, dimensions just turn raw data into business-friendly context, and they're used to be able to slice, filter, and group facts in meaningful ways. Anything to add on this?
Well, I think that's fantastic. I think that really gives people kind of a good lay of how to think about the difference between facts and dims and how they really want to structure those.
I wish I had had that when I first started in the BI space.
Awesome. So let's hand it over to Stephen to go over some dialogue you might have with your stakeholder.
Yeah, so we're gonna walk through a couple of different kind of sales data needs, and then I'll pitch it to the phData team where they've seen these real world examples. So to start, you can see kind of track every sale. So you get this question from some of your users or business leaders. We just need to make sure we're tracking every sale, who bought what, when, how much they spent, and if they got any discounts. And you can kind of break this down into a couple of different objectives based on that. So like we need to record who made the purchase, we need to capture what was purchased, track the purchase date and time, log the amount spent, and then note whether a discount was applied. So how would you guys break that down into kind of like a fact and dimensional model?
Yeah, so when you're getting this information, a business user is giving you this is obviously not very technical requirements. This is being fed information from a business user of how they would talk. Going back to the bus matrix, if you're looking at this, they've pretty much told you the business process in this case is going to be sales data. And then they've gave you some additional attributes of, hey, I need to be able to track date and time. I need to be able to log the amount spent. So I need to be able to grab totals. So they've given you the business process, sales, they've given you measurable columns, and they've given you attributes that you need to think about in terms of your dimensions. So just based off of this information right here, I know I have a sales business process with a sales fact table. I know that I'm going to have a date and a time dimension that's going to need to exist here. And I know in my fact table, I'm going to need to capture the amount And I'm also going to need to capture if there were any discounts that are applied within there to be able to accomplish what they're asking for here.
Yeah,
Anything
no,
else, Aaron, Dakota?
no, no, perfect. You guys hit it on the head. We'll go to the next dialogue.
Okay. The next one is going to be knowing about your customers. So it'd be great to know a little bit more about our customer base, like what type of customers they are and where they're from. And so similar to the last one, we can break this down into like kind of three different requirements, which is we need to identify the customer type, we need to record geographical details, and then we need to store this info in a way that links back to their purchases. So how would we break that one down?
Yeah, in this case, they've pretty much told you what the dimension was. So our dimension is going to be a customer dimension that we know we're going to need to be able to create. And they've already given us some information about the attributes that need to be captured within that customer dimension. Things like customer type, geographic details we can capture in that. And then in terms of storing it in a way that can link back to sales, we would just need to create that customer dimension. We're going to create that dimension key that exists on it. And we're going to create a link within our sales fact table that's going to be able to link those two things together. So everything that's available in customer in terms of attributes are going to provide a way for them to be able to slice and dice and group and filter the data that exists within that sales fact table. So going back to the previous one, amounts and discounts, I'm going to be able to slice and dice that data based on any of these new attributes that get added.
Exactly. This is starting to lay our foundation for one of the pieces of dimensionality that we want to filter on, but within the context of our conversation, we know we're still talking about sales data. So we need to link back to that fact we've already started to establish in the first piece of dialogue. How about this next piece?
I think if we ever do a V2 of this, we'll have to ask the audience to identify the facts and dimensions and do some basic modeling or something like that. But yeah, so for this third one, our objective is to understand our product performance. So I want to see details about our products, what category they're in, the brand, the SKU, so we know what's selling well. So basically, just think about like product performance across all their different segments.
Yeah, similar sort of thing of what we saw with customers here. So it's going to be, you're going to need to create a product dimension here if we don't already have one, and we're going to need to capture some additional attributes there. So capture things like categories, capture things like brand information, and the SKU within a different dimension. So now you have your sales business process, which is going to become your sales fact table. And if you think about it in terms of that bus matrix, now you've got links to a customer and you've got links to a product. And again, you're going to join those up within that sales fact table. You're going to have an additional dimension key or foreign key relationship back now to your product dimension table.
Very much so. Let's go on to the next.
All right. Now we're going to be looking at tracking time. So the question is, we should be able to track when things happen by day, month, and year, so we can start to begin spotting trends over time. And personally, I've worked with a lot of date data, and I know that it's sometimes can be some of the most painful parts of the data modeling process. Take it away, guys.
Yeah, no, I think you hit the nail on the head. So you may notice a common theme here as we're asking some of these questions. So again, like we've identified a different way to be able to slice and dice and group and filter data. In this case, it's going to be using date and time. So you would want to create a date and time dimension. These are pretty typical ones that you're going to have pretty much in any warehouse that you're building where you're going to structure this out. And you may be asking yourselves, why would I create a date and time dimension? Isn't it one value? And the answer is no, because you can have different variations of a single date. Think about it in terms of a date. You can have the weekday. You can have different characters used to describe a single date or a weekday. You have months, you have years, you have quarters, you have fiscal values, you've got day of week. There's literally hundreds of variations of a date that can exist within your date dimension. So when you join it, and you may just join it on a typical date to be able to join back to that, you can potentially have hundreds of other variations of that date that give the ability to slice and dice your data without someone going into a single table and adding all of these different calculations into it to be able to look at it. Same thing with time. You can have hours, minutes, seconds, day, time of day. There's a lot of things that you can capture into it that you can use to look at that. So if you think about this again in terms of our bus matrix, now we've got our sales business process, which is going to be our sales fact table. And now we've added dimensions for customers, product, date, and time to be able to join to those. And we're going to link those up to that fact table at the end.
Very much so. I think one of the important things is, again, this is about standardizing our date and time. We could let everyone decide how those roll up, or we can have one singular dimension that the whole organization adheres to, because often the organization does adhere to some type of calendar, whether that's a fiscal calendar or the actual calendar year. All right, it's time to start connecting the dots.
So I've been kind of ignoring it so far, but you guys might see like the stat inventory kind of data panel. So like this one's more of a kind of a quest, right? Like now we have a question from business. We got to go do a bunch of investigation, hopefully find the right NPC to talk to in the company. In this case, it's all the sales info needs to link back to the right customer, product, and date, so our numbers make sense. So how do you do that without an exclamation mark telling you where to go?
Yeah, exactly. So with what you've built in the previous steps is you've kind of built that foundational layer. You've made it really simple. You've made it really understandable to the business. You've cleaned things up. You've labeled things appropriately. You've got the foundational layer to be able to go and do that. So there's a few different options that you can take for them to actually be able to start consuming and understanding data from this. One, as we talked about earlier in this presentation, I can put a one big table that sits on top of that that pulls this together and does this very simple joins and go and collects these values and applies that aggregation. Or I can take my BI tool. If I'm using a Tableau or Power BI, I can sit it directly on top of my dimensional model and give my user or my data analyst or potentially even my business user the ability to go and start pulling stuff from that data. That BI tool already knows how all of this stuff connects based on just kind of how I laid out the model in it. And they can go and start dragging and dropping and creating measures on top of this data to get the information that they're looking for.
Exactly, exactly. And so with that, it's time to summarize our insights.
All right, this is our last one. So we have a customer saying it'd be awesome to get quick summaries like sales by customer segment, region, or product type and see totals, quantities, and discounted patterns.
Yeah, and I think this is just what we said in the last one. And maybe the last one was supposed to be where we connected dimensions to the facts. And I may have jumped ahead of there a little bit of how you kind of build it in the foundational layer. But yeah, here the components are already there for you to be able to answer these questions. The good thing about like with dimensional models when you're building this is it's not just these questions that you can ask and get answers to. There's literally thousands, hundreds of thousands of other questions that you can ask now where you can go in and ask it against this data, and it's pretty easy to be able to get those different things out. So think about it. I want to group by product category and type. It's just pulling those together and then put a group by on it. Or you can again you can do these within the BI tools and things, etc. You've done the hard work. All the hard work is going to be in the pipelines to be able to get it to that denormalized state. So you've already done the heavy lifting. It's just now you're just consuming data from that.
Exactly, exactly. And if we look here, this is just an example of how you would bring those together, how you would link your primary keys and foreign keys together, create that cells table to where you can start to quantify these things. And now you can ask new questions you didn't even think of. Maybe you want to start understanding what products are selling well in what segments and what regions. Do we see relationships where after a certain product starts selling well in a segment, other products start selling well as kind of follow-up? Should we start doing recommendations based off those? Do we see a kind of a lag based off of common buying patterns across region and segment, etc.? Those are questions the business didn't initially ask, but they can get that answer with this model still in front of them. And this lays those foundations that, again, we focus on building around the business process, building around what dimensionality the customers need. And so with that, let's talk about what are some best practices for long-term success as you're starting to build out dimensional models. We've said this before, we'll say it again. Always start with the business in mind. Make sure whatever you're modeling should be solving for a business process so that way the business can start to answer their own questions and ask new and interesting questions. We want to make sure we are very clear about what the grain of our data is. It is very painful to build out a model and then realize you were at the wrong grain and we need to go even lower and potentially even significantly lower. That can incur a lot of technical debt as you start to work on that. Make sure we conform our dimensions. Much like Dustin already said, we should really be mastering a lot of that data because it is important. And the more conformed it is, and the more we're all sharing it, the easier it is for all of our definitions and calculations and dimensionality to be the same, and for numbers to start tying out across business processes. We want to keep it simple. Don't over-engineer. If you find you only ever need a dimensional model, you don't have to go build a data vault. Only build what makes sense. Keep it simple. Focus on clarity and reusability. Manage your slowly changing dimensions. Understand what data you actually care about the changes of versus others, as well as make sure you have a very good governable process on how you're going to evolve your models incrementally, how you're going to handle breaking changes, things like that, your keys, so that way you don't cause an outage in something downstream from you. At the end of the day, what will come out when you've done that is a dimensional model that scales well for the business, is understandable, and is reliable, and that people enjoy using. Dustin, Stephen, anything you guys would like to add to that?
I think you covered it well.
Agreed.
So,
All right, looking at the real world lessons here as we start to wrap up. The key thing, I mentioned this early in the presentation, when we as consultants go in and we work with folks on DBT projects, especially if we're not there from the beginning, generally when we go in and evaluate and analyze what they're doing, most of the time the problems relate back to the underlying model, where they just went in and started building and it worked for a period of time and then it just reached a point where it couldn't scale. DBT as a whole is a pretty easy tool to use, and it's a very flexible tool to use. It's one of the reasons why I love it. If I misconfigure something, generally I can go in and make those changes. The one area that's really hard to go in and fix is the underlying model. Unfortunately, there's no easy button there to go in and fix that when you hit a point where you can no longer scale. So it's something really important to really put a lot of thought into and think about up front because it's going to save you some headache later. You may feel like it may slow you down a little bit in the beginning, and there's even some truth to that because getting started with it takes a little bit of time because you got to build out your dimensions and it's very important that your data is right. But over time, it's going to enable you to scale and grow significantly faster than if you haven't done it. And you can potentially save yourself lots and lots of money from calling folks like me in Dakota to come in and help you. Although we're always very happy when you do that because we love being able to work with our customers. But other things, again, kind of hit on these delayed pain. So the impact from a poor data model design is often not realized until it's too late. Um, there's a high cost to fix. Again, there's no easy button here to be able to just go in and say, I messed up. Let's go ahead and adjust it. It's generally a pretty big lift. Do it first. Modeling should be the first thing that you do. Anytime we work with someone on doing a new implementation of DBT, I know we're engineers and we want to get in there and we want to start building stuff, but take a step back to think about what you're building before you start building it. Your first thought, as soon as you sign that purchase order, shouldn't be to go in and start building things. It should be able to step back and look at the big picture of what you're going to be building. And then value over debugging. Teams with good data models spend more time delivering value and less time fixing issues. So the takeaway here, and what we hope resonates with you all, is strong modeling up front pays dividends in scalability, cost savings, and business impact. Take it from us. We work with customers doing this stuff every day. This is super, super important, and in my opinion, is the most important aspect of building with DBT is think about your model.
100%, 100%. And while it might feel slow at first, remember sometimes you've got to slow down to go fast.
And then just so DBT can repeat some takeaways, I will re-mention some of them. So at a high level, like we've said, all kind of day, you're able to avoid chaos and costly fixes when you put a little bit of effort into your data modeling. I always say like you can either have pain now or you can have pain later. And typically the pain now is going to be a lot less than what you experience way later after you've invested time and effort into something. Um, Scalability and flexibility goes back to how we were just saying by like following some of these best practices and putting that effort in to think about like some down the road kind of scenarios. means that you're going to enable your data team to move a lot faster when it comes to solving problems because they now have a foundation of how to access it. It's going to be a lot cleaner, easier to work with and understand. And DBT is going to try to align with that process to, do the documentation generation, the testing, all of that to enable a very clean pipeline that answers those kinds of problems and lets you scale effectively. And then lastly, that foundation for reliable insights. Now it's more important than ever. We're seeing so many tools being built off of semantic layers and all these kinds of downstream data models. It's really important that we're able to build something that's going to be able to have reliable information that we can then feed into whatever those business challenges are. But thank you all for taking the time to kind of talk with us all today. I'm going to hand it over to Leah to end the webinar. But it was great talking with everyone.
Thanks, everyone.
Thanks, Stephen. Okie dokie, I've got some next steps here for y'all. So you can connect with DBT Labs and phData experts. You can click the Talk to an Expert button here at the top right-hand corner of Goldcast. You can also get a DBT Architect certification. It's a proven way to verify you're a DBT expert on the DBT platform. So we'll send a link in the chat for that as well. And then I'd also like for y'all to join us for our Fast Track to DBT workshop that is coming up here at the beginning of October. In that workshop, you'll get a guided intro to the DBT platform. At the end, you'll walk away with a working DBT project, a solid understanding of DBT basics, and ideas for how to use DBT in your own work. It's a really great workshop. And then lastly, we launched a survey in the chat. I hope that you take that survey. We'd love to get your feedback on today's session. And thank you all so much for joining us. Stay safe out there in the analytics wasteland. Bye.